Have you ever wondered what a quantum computer is and how it works? Quantum computing, a term that often buzzes around tech circles, can seem like a concept from a futuristic novel. But rest assured, it is very much a part of our present, and it promises to revolutionize our future. So what is quantum computing? It's a type of computation that harnesses the extraordinary laws of quantum mechanics to process information. It's starkly different from classical computing, the type we're all familiar with, where data is stored in bits. These bits can be either a 0 or a 1. There's no in-between. Quantum computing, on the other hand, introduces a game-changing element, the qubit. Qubits, short for quantum bits, are the basic units of quantum information. Unlike classical bits, qubits can exist in multiple states at once, thanks to a quantum quirk known as superposition. This means that a qubit can be a 0, a 1, or both at the same time. Now imagine a computer that can process multiple outcomes simultaneously. That's the power of quantum computing. It opens up a realm of possibilities, enabling us to solve complex problems, perform high-speed calculations, and even simulate the very building blocks of our universe. But of course, quantum computing isn't just about superposition. It also involves another quantum phenomenon called entanglement. When qubits become entangled, the state of one qubit becomes linked with the state of another, no matter how far apart they are. This allows for a level of coordination and communication that's simply beyond the reach of classical computing. As we delve deeper into the realm of quantum computing, we find ourselves in a world that defies our everyday understanding of reality. A world where information isn't just binary, but can exist in an infinite number of states. A world where particles become entangled across vast distances, creating a new dimension of connectivity. Quantum computing, then, is based on the principles of quantum mechanics, which is a departure from classical computing. And as we continue to unlock its potential, we're not just pushing the boundaries of technology, but also redefining the very nature of computation. But just how powerful is quantum computing? Quantum computing, the revolutionary technology of the future, holds an immense potential that can surpass the capabilities of classical computing. Imagine a computer that can perform calculations at a speed and depth that are currently unimaginable. This is the promise of quantum computing. Quantum computers are not just faster versions of our current machines. They represent a fundamentally different way of processing information. They can solve certain problems exponentially faster than any classical computer. For example, think about factoring large numbers. In classical computing, this is a time-consuming task. However, a quantum computer can factor these numbers in a fraction of the time. Another area where quantum computers shine is in simulating the behavior of matter at the molecular level. It's a complex problem that classical computers struggle with because it requires a level of computational power just beyond their reach. But quantum computers? They're built for this. They can handle the complexity and offer solutions that are currently out of our grasp. It's like having a supercalculator that can juggle multiple calculations at once. This is due to the properties of quantum mechanics, which allow quantum computers to process a large number of possibilities all at once. Instead of working through one calculation at a time, as classical computers do, quantum computers can process multiple possibilities simultaneously, vastly speeding up the computational process. So, when we talk about the power of quantum computing, we are not just talking about speed. We're talking about an entirely new paradigm of computing, one that can tackle problems that are currently unsolvable and open up a new world of possibilities in science, medicine, and technology. This potential is truly awe-inspiring, and it's why researchers and tech giants across the globe are pouring resources into developing this technology. The race is on to unlock the full potential of quantum computing. The power of quantum computers lies in their ability to perform many calculations simultaneously, thanks to the properties of quantum mechanics. So, where can we apply this quantum power, you may ask? Well, the potential applications of quantum computing are as vast as they are exciting, and they span across a multitude of fields. Let's start with cryptography. You know, the art of writing or solving codes. Quantum computing could potentially turn the world of cryptography on its head. Because of their superior processing power, quantum computers could crack codes that would take classical computers centuries to solve. This would have enormous implications for our digital security, making our online interactions more secure than ever before. Moving on to optimization. From logistics and supply chain management to financial modeling and portfolio optimization, the world is full of complex optimization problems. Quantum computers, with their ability to process and analyze massive amounts of data simultaneously, could provide solutions to these problems in a fraction of the time it would take traditional computers. Next up is machine learning. Machine learning algorithms are all about recognizing patterns in data. Quantum computers could enhance these algorithms, allowing them to learn and adapt at a pace that far outstrips anything we've seen before. This could lead to breakthroughs in fields as diverse as climate modeling, financial forecasting, and even the way we discover new music. Lastly, let's consider drug discovery. The process of discovering new drugs is often a long and complex one, involving the analysis of vast amounts of data and the testing of countless molecular combinations. Quantum computing could help speed up this process enormously, making new treatments available faster and potentially saving countless lives. So, from cryptography to optimization, machine learning to drug discovery, the potential applications of quantum computing are truly staggering. The power of quantum computing could revolutionize these fields by solving problems that are currently beyond the reach of classical computers. The applications of quantum computing are vast and could profoundly impact many sectors. Quantum computing sounds promising, but what challenges do we face? Entering the realm of quantum computing is like stepping into a new world. It's a world of immense possibilities, but it is not without its share of hurdles. Let's take a moment to explore these challenges. First off, on the technical side, maintaining quantum coherence is a daunting task. Quantum coherence, the ability of quantum bits or qubits to exist in multiple states simultaneously, is the essence of quantum computing. However, this delicate state can be easily disrupted by environmental factors like heat, radiation, and electromagnetic waves. This phenomenon, known as decoherence, can lead to errors in computation, making it a significant challenge for quantum computing. Another technical challenge is controlling quantum systems. In traditional computing, we're dealing with bits that are either 0 or 1. But in the quantum world, a qubit can be both 0 and 1 at the same time, thanks to a phenomenon called superposition. And when we have multiple qubits, they can be linked through a process known as entanglement, where the state of one qubit instantly affects the state of another, no matter the distance between them. Managing these complex relationships requires incredibly precise control and manipulation. On the societal side, quantum literacy is a pressing issue. Quantum computing is a complex field that requires a high level of understanding of quantum mechanics, a subject which is not widely taught or understood. To truly harness the power of quantum computing, we need to foster a new generation of quantum literate professionals. Lastly, we must consider the ethical implications of quantum technology. With its potential to crack traditional encryption methods, quantum computing could pose serious threats to data security and privacy. We need to establish robust ethical guidelines and regulatory frameworks to ensure that this technology is used responsibly. While quantum computing holds great promise, it also presents significant challenges that we must overcome. So, let's summarize what we've learned about quantum computing. We started our journey by demystifying what quantum computing is. It's a type of computing that uses quantum bits, or qubits, instead of the classic bits we see in our everyday computers. These qubits have the magical ability to be in multiple states at once, thanks to the fascinating principles of quantum mechanics. We then delved into how quantum computing differs from classical computing. While classical computers process bits in a linear, one-at-a-time manner, quantum computers can process multiple computations simultaneously. This unique feature of quantum computing gives it a potentially massive advantage in terms of power and speed. Speaking of power, we explored how quantum computing, with its parallel processing abilities, could outperform even the most advanced classical computers. problems that would take classical computers thousands of years to solve could potentially be solved by quantum computers in mere seconds. It's like comparing a horse-drawn carriage to a supersonic jet. Next, we touched on the various applications of quantum computing, from simulating complex chemical reactions to optimizing logistics and supply chains, to breaking or creating more secure encryption codes. The potential uses for quantum computing are vast and varied. However, despite its immense potential, quantum computing is not without its challenges. We discussed how maintaining quantum states, known as quantum coherence, is a significant technical hurdle. Additionally, quantum computers are highly sensitive to environmental changes and require extremely low temperatures to function, further complicating their design and operation. But let's not forget, every great innovation comes with its set of challenges. The key is to persistently work towards overcoming them. As we continue to explore this fascinating field, we're making steady progress in addressing these challenges and getting closer to realizing the full potential of quantum computing. In conclusion, quantum computing is a complex and challenging field, but it also holds great promise for the future. As we continue to unravel the mysteries of the quantum world, we may well be on the brink of a new era in computing.